All right, good afternoon, everyone. Thanks for coming to my talk. My name is Bill Berzinskas. I'm the Senior Director of Engineering at Teamworks. Our products empower over 300,000 elite athletes. So these are Division I all the way up through Major League Soccer, international rugby, just all over the globe, professional athletes using our product, which streamlines dozens of their day-to-day workflows that are essential to their success, right? You think about an NFL player, he gets to practice late. He gets, maybe a $10 million fine for not being on time. So our platform helps them be more punctual as they travel, helps them communicate as teams. And then we're layering on a couple of other pieces, a few more products here, Influencer Note Meal, dealing with different facets of the athlete's life. So the presentation we're going to see today, it's probably not as technical as you would expect for something that starts out with the word Terraform. It's a little bit more about our journey, the complexities in our journey, and there are absolutely a few clever tricks with Terraform that we're going to look at. The key innovations here, right? Like one, we reorganized our project immensely. A few novel patterns, a few parlor tricks here and there. And we started really buying into cloud native way more, and that's what makes all of this go around. You may hear a few, yeah, duh, that's a best practice, of course, and that's okay. They seemed worth reinforcing to me, so I add them. And you may also see a few places where we kind of bend the rules. We don't adhere to kind of by the book Terraform practices in some areas. So this is Teamworks in a nutshell. It is a single instance multi-tenant application. It runs on Amazon. The ops stack, like I said, heavy on Terraform, heavy on Kubernetes. Today, we want to look at how we handled building out both our disaster recovery and our global distribution strategies while trying to stay compliant with global data privacy regulations. So let's take a look at where we started, right? In the beginning, in the before times, as we sometimes call them, we had a really simple deployment strategy. We used we used Ansible, we used EC2. Later, we got into Docker and containers and things. Through two partner projects with Amazon, one was moving up a Postgres major version and the other migrating into EKS. We inherited a little bit of Terraform. It was pretty standard stuff, right? We had a folder full of modules. We had a folder for each environment. Every environment had its own main TF. The modules folder, in this case, was shared with bespoke modules that somebody I've never met wrote. And what we found was, as we start to add more and more resources to the stack, we're redefining the same resource many, many times. The only difference really is in like the quality of service, the resilience parameters, things like that. And it really starts to bother me, right? We make a change in staging, maybe it's not backwards compatible with latest. We're just not able to work very effectively as we build onto it. So we find three problems that we want to solve, and we want to use Terraform to help us solve. As a growing SaaS business, we want our customers, more importantly, want disaster recovery. We want it too, but they want it more. They want things like sub 5-minute restore times, sub 1-hour failovers. And to date, this had all been a documented manual process. It was very scary. All the people who had created it had left the company at this point. And it was terrifying to think about executing it. So we just hoped that nothing went wrong, right? The second problem was expanding our business. We want to have a global reach. We want to also meet different levels of compliance, GDPR, California data privacy, and so forth. And these things were kind of at odds with each other. We had a bunch of US customers. We couldn't do some of the typical replication patterns of just make the databases global, right? We would break every privacy law in America. We also found in the multi-region expansion planning that some of our customers not only were in places that had horrible internet and horrible latency, but they traveled to places where it was even worse, right? So if you start to look at latency times for places like Cape Town or Sao Paulo, very routinely over a second at some points in the day. You have request flight paths that go from, say, Cape Town up through Africa, into Europe, across the Atlantic, and the end-to-end request time was completely unacceptable, right? The final part, all of this is going on. The business wants to keep growing, right? And we want to keep growing not only around the world, but we want to keep growing in the sports industry, and that's really difficult because they don't make new sports teams every day. So the way that we see to grow there is mergers and acquisitions, investing in other companies, partnerships into our platform. And in doing that, we start to realize even more complexity, right? For any new company, there's variables. We may need to just optimize the existing hosting platform. We make a couple edits, change some policies, we're good. In more extreme cases, maybe we have to completely redesign their hosting infrastructure, right? We're talking about apps that are on Heroku, apps where one guy set up all the stuff in Amazon, has no idea how it works, things like that. And for some of these smaller platforms and products, we also want to uplift them to the compliance standards of our other products. So we start iterating on disaster recovery first, right? Here we are, we're in North America, US East 1. We want to fail over to East 2. Seems pretty simple, right? So now we have a module EKS in each region. We start tacking things like secondary onto it. And, you know, like, we start to see more copy and pasta as well, right? There's inconsistencies in this approach. The primary EKS may not match the secondary EKS. Somebody may have missed it in merge request or whatever. But we start to see a lot of drift here as well. Testing starts to get more and more complicated. We basically need every change needs to be applied and watched by a human. Some environments need the failover, right? Our production, US East 1, that's 100% of our customers at this time, has to have failover. We start to scale to other parts of the world. We have smaller clusters. We have 0 clients initially. And then also, this holds true in our development environments. Like, we just don't need the failover capability. Like, we can rebuild the development cluster faster than we could fail over it at this point in time. So then we say, okay, well, we won't define the differences, right? Like, our staging environment, maybe it doesn't get attached to this. Well, that's a bad example. Our latest environment doesn't get attached to this. So we don't define the code. And then later, maybe we figure out we do need it. So now we put more spaghetti into the project, right? And then we start to think about the actual global transition. So we take North America, we replicate it to other countries. This causes a lot of nightmares because we start using words like secondary, tertiary. I think we thought it was called quadtiary at one point, but it's actually not. But these words, like, it makes it very difficult not only to implement, but to think past those types of numbers. If we want to DR into more than 4 regions, what are we going to call that? We also end up maintaining these duplicate definitions of the main TF more, right? We have 2 EKSs here, we have an EKS here, we have an EKS there. They are all drifting. The complexity is intensifying. People's tensions are running really high, and all we want to do is like scale this app to end regions around the globe, right? We didn't even talk about the environment side of it yet. We have a latest environment, staging, production. So now we've got primary, secondary, prod, stage, dev, et cetera, and we're just basically spreading headaches around the world. So for any given resource in this model, say it's a database, right? We've now defined 1 for each environment, latest staging production, times 2, because we need a primary, we need a failover, so we're at 6, times the number of regions. So we see 3, 4 regions there. So we're in the 18 to 24 range somewhere. You can imagine the drift problem at this situation, right? Like, I want to go work on that cluster. Well, I broke all the rest of the clusters, so that was probably a bad idea. Obviously, though, like, we use more than just databases. So in looking at this problem, we're also talking about hundreds of Terraform resources, thousands of lines of Terraform code, all to define the same platform, and just nuanced differences between it. Building new at this point is cumbersome, if not impossible, right? We start adding a couple new SREs. This complexity is not something we can stick in somebody's head on a 30, 60, 90-day plan. So it gets worse, right? We can't legally replicate some of this data. Like I said earlier, like the US collegiate segment, I cannot put that in the UK. I will get arrested. We learned about 2 fun topics at this point of our journey. Data residency. So this is the locations at which data can be stored and processed, right? So if it's in memory, it's probably squeaks by. If it's going to file system, if it's going through a CPU, it basically has to happen in one specific zone. The second part of it is data sovereignty. So this is the customer's right to mandate or dictate to us where that data residency zone is. So this means that our UK customers can say, we don't want you to ever process in North America. Kind of the opposite situation of our collegiate customers. And there are instances, we just can't move this data around in other ways. Like we think about Aurora Postgres on Amazon, it's not really multi-master. They may fake it for us a little. So replicating in some of these areas, it just gets really, really messy. So table flip, we're done with that. We got to start over. We've just showed you a few iterations of bloat, redundancy, and inconsistency. Now, with a small SRE team, a really big product development team, we have to figure out how do we finish building sort of active disaster recovery and failover capabilities? How do we add N regions infinitely while keeping those DR capabilities? How do we keep it simple? How do we keep it legal? And as we add more applications to our portfolio, and we continue to build and scale the products we have, like, how do we do all of that at once? So it's happened to us all. The boss comes in. Great news, everybody. I found these 2 Medium articles. They're really going to change our life, right? In all seriousness, the 2 articles we're going to look at briefly, they forced our team to have some really deep conversations about how we'd structure the project. They forced us to define and enumerate the goals. And they also involved a small amount of late-night mad science, excuse me. So first article is called Terraform Skeleton. Okay, and this one varies a little bit from kind of the textbook Terraform. They suggest an approach where you have these components that kind of layer into your stack. Right? You've got your compute component, which probably has to have some IAM policies beforehand. And I like that. It makes me think, like, as a developer, I have this, kind of separation of concerns, and I have a good organizational place to put some of my bits. But some of the complexity still winds up in these environment folders, right? I still have a dev and a prod main TF. They have separate variables, so if I add one to dev, I have to add one to prod. I hope I got those both right. The main TFs, they can drift across environments. And this article also says that we should pass out files, or the result of plans between the components. It's kind of new for us. It wasn't really a deal breaker. I'm pretty sure I would screw it up doing it as a human. The second article is more about multi-region. It's very similar in design in some ways. They push a lot of the complexity into the var files themselves. So in their model, they basically, each of the TFRs for the region and environment pair, everything goes in there. All the nuance difference goes in there. The main TF kind of is still an issue a little bit, right? And we still have very similar problems with the variables files, the outputs, and things like that. But it gets us a lot closer, right? The kind of module part is a little more reusable. The configuration part is a little more kind of consistent. So we go on a vision quest, right? We talk about these two articles for like weeks. We go into basically a pit of snakes, right? And most of these snakes are in how we configure the application, and the remainder of them is just making sure that we're just not duplicating and sprawling all of our IEC. So we fight the snakes off. I think James got a snake bite or two maybe in the process, but we came out stronger, and most importantly, we kind of decided on some patterns that we decided to use and grow with. So we're going to look at kind of the 7 loose requirements for how we pulled this off. Okay, requirement 1, don't roll our own modules. Right? For years, we had been writing modules for everything. It feels great. We're Terraform developers now. Hooray. But there's far more qualified people than myself or some of my team to do that kind of work. And to do that kind of work to a level where you can attest to its compliance, you can attest to its security, you can attest to the licensing of it. A lot of the stuff that we found in the HashiCorp registry, it had reports for things like compliance. It had communities of developers, right, talking about not only how the module works, but like how it doesn't work. Like when it breaks, if we write the module and it breaks, who are we going to ask? Ourselves. And we broke it, so maybe we don't know. It should seem kind of like, well, yeah, duh. Like, do the off-the-shelf thing, don't roll your own. But we also wanted to take the opportunity to learn from the Terraform community, right? Just because we use the modules doesn't mean we can't open them up, look inside them, see what other people are doing. And I think that's been really, really phenomenal just to help us level up on some of our techniques. Package managers, open source packages, all very great. One of the big challenges here for us, like pinning versions, and really being kind of strict about dependencies, yeah, sure, duh. But like you have to come back around to it. You can't let those dependencies and modules rot. We had a couple situations where we did just that. We're in the process of transitioning from x86, or x64 to M1. Team can't run Terraform anymore, right? And that's because we weren't keeping up with the community. Topics like hacktivism. Right, somebody puts a line in the package. You don't notice it, right? A good example, I think we talked about the one you see in the HashiCorp registry a lot about Putin. If you set this flag to false and say, no, Putin's an all right guy, it will destroy your Terraform resources. It'll just rip them right out of the cloud, right? I understand why that guy did it after reading more into it, but it's things like that where when you're not aware, you don't have the opportunity to look at the source and see what it does. Like, you can't be compliant with code like that. Requirement 2, we want to group like things and layer them into a stack. We talk about stacks all day. Developers, ops people. We wanted to make little blocks, right? I need a network before I can install databases and message buses. I need almost all that stuff before I can start thinking about compute. The challenges that we saw here are really in sharing configuration, right? We have a Route 53 at the top center. Maybe the CloudFront in storage needs some of that zone information, right? We need to be able to pass things up and down the stack a little bit. We probably did some bad things to the Terraform dependency chain. By operating like this and not sort of in a more monolithic Terraform blob, we're breaking that dependency chain. We can't destroy cleanly. We have to kind of start at the bottom of the stack and work our way back up. Probably the most challenging part of it all was really just figuring out the semantics about component composition, where responsibilities lie. And we wanted to try to find some ways to use this pattern to also minimize a lot of overlap that we see in our greater enterprise hosting stack, right? We have other applications that use almost all these same tools. So when we look at our implementation of this component layering approach, on the left side here, we see all of our components, right? Every single one of those is similar in construction to a Terraform module, but it is managing all of the concerns of that particular piece of the stack, right? So we look at the data component. It's handling OpenSearch. It's handling Redis. It's handling Postgres itself, right? Its responsibility is data storage. We do maintain 2 custom modules. You see our little modules folder on the bottom. That's my bad. I didn't want to blow up any databases or anything, so those guys kind of made the cut from requirement 1. The right side is inside of the data component. We looked briefly, it does these AWS things, but there's a little bit more here. It is basically allowing us to switch state backend by selecting one of the TF-vars files at the top. This is an example at the bottom. All it is the bucket and the DynamoDB lock. Locals file, just kind of local variables and translations, interpolations, and things. A single variables file, a single Terraform TF, and no other differences. This component gets applied to every single environment. We pushed 100% of our complexity straight into this values file, or the variables file, that we'll take a look at briefly in a second. What we do is when we Terraform init, we say use that backend config for staging or production. It switches out all the stuff here. And then we open a workspace. Our workspace nomenclature is environment-region, right? So production-US East 1, for example. And then once we have that, we can apply that component. The third requirement we had, we wanted this to be completely pipeline first, right? We big proponents of GitLab, of CD. I think the book Accelerate has been our guiding light for some 3 or 4 years now. We had to become capable in the areas that that book describes. We were shipping 5 to 10 production releases a week. We templated all the pipeline steps for the application, right? Things like building Docker, building NPM, pushing to S3, Helm, Argo syncs, it's all just templated. We had never treated the IAC that way. And until we do, I think we're going to be the people running the Terraform every single time. And there's, I don't know, 5, 6 of us. So you can imagine that it gets a little dicey. We wanted our IAC to follow the same standards that we hold our product development teams to. So we wanted our infrastructure releases not human-driven. We wanted them to have good visibility coming to the SRE team. We created some job templates in GitLab, 2 in particular. One is the overarching pipeline for the IAC. The other is a child pipeline that is run for each component. And that child pipeline is responsible for sort of lint, plan, apply, depending on where in the SDLC you are. So the customers were happy on, with the application and how fast we're shipping the application. We want the developers to be happy, to be able to iterate, build new services faster. We felt that this was table stakes for that. Like, we had to have this. The human side of it, though, like, we could not do any of this until we had the SDLC mapped out, right? We had to go from 2 or 3 guys doing Terraform applies off their laptops to, like, what is the workflow? When I do a merge request, like, what happens in Terraform? So what we've decided is that when a merge request is submitted, basically it's going to run a plan. When it gets merged into a target branch, we use sort of the environment branch strategy. So if I'm merging into staging, that merge is actually going to go and do the Terraform apply. It's terrifying. So scary the first time we did it. And then because of the pipeline, right? Like if we follow the first article's guidance, we're now pushing Terraform outputs between these stages, right? So we have to use things like caching and artifacting. It's just a drag. We did not like it at all. So we wanted to decouple the inputs and outputs and the overall state of the component. We just didn't like the thought of sharing these output files, right? Like as I said earlier, like if I'm the developer and I'm trying to intervene or debug, and I've got to make sure that the right out file goes into the right other one, I'm going to mess it up. I'm going to pull an out file that's outdated or from the wrong environment. I'm going to switch directory. Yeah, I got this. Boom. Just took down production. In the case of the ultimate failure, right, like I, the human, have to be the pipeline. So that's not acceptable to me in the design of this. Instead, our approach, literally tag everything. We put the environment, the application, which Terraform component, which subnet tier, as much information as we can kind of structure on our resources. It allows us to query it back easier later. There's a tiny small dragon that I alluded to earlier, and it is very specifically because of this. Because of both splitting the components and this decoupling of state and querying of state, we really can't destroy the whole thing in like one fell swoop. So just be aware of that. Querying across components in practice, right? Here we see at the bottom left, we've got a VPC. Like you have to have it in AWS. So we need to use that VPC ID for almost every other resource in the application that is bound to a network. And we need to get that across the pipeline boundary as well. So because we require region and environment as inputs, we tag those, right? They're on the provider. Provider says default tags, everything gets all this. Because those two kind of come in specifically, we can then do a pretty good job of querying them back out. So here, bottom right, this is our data component, and we're actually doing a lookup to find the VPC, and then we're filtering by these tags, right? We want to find the VPC for Teamworks production. Great, there you go. Now our component has what it needs. We've just decoupled that in so many words. And we can also kind of do some other cool things at some point, right? We can use these same tags for cost attribution. We can say that the Teamworks Hub product, var application equals Teamworks. All of those resources are billed to a particular cost center, right? And yeah. Requirement 5. It's so obvious in software development. Keep it dry, obviously. But sometimes it's hard to. Like, you can't always have the most driest code. The best thing that we could figure to do was to make it intentional and meaningful when we had to intentionally be less dry, right? It's been the hardest to not create monolithic shared config blobs, kind of moving our monolithic Terraform problem over into a different place. But we have a few kinds of things that we see be less dry, right? We have static things where we just copy and paste them, or they're in multiple variables files. These tend to be things like Route 53 zones, CIDR blocks, things that we don't really expect to change often. We handled that particular problem with a crafty little piece of JSON. We just put it in a JSON blob, we pull it back into our locals. Route 53 zone names are never going to change for us, so we're pretty okay with that. We still have a bunch of other configuration left. We still have a lot of areas where the main TF may start to show some of the repetition. So we decided to move a lot of that into our locals file. And a lot of the preceding slides are going to be about some of the tricks we do in our locals file to help us manage and separate all these problems. It's also worth calling out, we saw in the data component a couple slides back, we did start off with like one big main TF at one point. We started splitting them out. We have our Postgres TF and our Redis TF. And that's been really great because it's like a module, but it's a lot more lightweight. And because of some of the bootstrap and boilerplate things we do, we can almost drop them into other applications when we need to. You need a Postgres, here you go. The other big side of our dryness problem was just the config itself, right? Every environment in some of the preceding models had its own variables file. So now I want to go and I want to see what the AZs are for production. So I've got to open production's variables file. We came up with a pretty nifty trick, and we were basically expressing config data through maps. And those map keys are our two Terraform inputs. Production US East 1. Here's the AZs. Well, is that the same as staging? Because we have it here, we don't have to go open another file for staging. We just say, yeah, it's right there, right? We can compare, we can see all of the config in all of the environments when we need to. Bottom right-ish here, like this is kind of how we slurp that up into our locals. Almost everything winds up with these pointers to the map. And the only thing that really changes is we start to define both our disaster recovery, US East 1, US East 2, and our global expansion, like AP Southeast 2. All of the difference is encapsulated in this one file. So step 6, now we're kind of getting into the good parts, right? We want to do disaster recovery and failover, but like we also have to prove it. We have a single bootstrap component that sets up a state file, and the lock, it replicates it to any region that we do business in. When a disaster occurs, we've got a very clever trick based on this region, var region that we just saw, and that's going to allow us to shift the whole state file and kind of the active operating region. The biggest challenge here, like requirements 1 through 5 had to be built before we could even really get into this part. We had to not blow anything up, right? Like production systems, we can't start to take control of them with Terraform and blow them off the earth and reapply them. Like there's customers using them. And we had to do a lot of small scale tests. Like there were some times where we just didn't understand behaviors. We had guesses about how things in EKS would work, for example, only to find out that they worked much differently and our worker nodes would go away. And during the testing, you know, like capture as much data as you can. Chaos monkey it, right? Like get even more data. In the lower environments, just like collect all the data that you can about your DR process. So we let the SREs, the platform team, and a couple developers tear it up for a little while. If someone destroys a dev cluster, just kind of track the time, you know, take some notes about the sequence of actions, post-mortem it, obviously, and keep doing it until it's uncomfortable, right? Like, get weird with it. Take your staging server down a few times a day. See how fast you can get it back online. See why you can get that one back online quicker, but maybe not a different one or a different service, right? And then break it harder, like just keep going. And this is important because by the time you get to do a production failover, like you need to know definitively how this is going to behave, right? Master rolling back the state, master moving the backends around the planet. Those are some of the first things we had to really get comfortable with. So what happens once US East 1 gets blown up, right? Like how does this actually go down for us? The first construct we introduced was account management region. And this is literally like where am I as the operator pointed at in Amazon. What this variable does under the hood, it's fed into the main Terraform provider. It moves that provider's references to the state file and such around. We also expose it as a Boolean though. And this is pretty cool. Like, it lets us do a couple of really nifty tricks with just a very simple piece of code, right? I want to install something once in my account. I don't want to have to be bound to any of the DR multi-region things. It could be a deployment token. It could be any other kind of vendor credential. So by having these two, more specifically is account management region, I can tell Terraform, like, only do it for operational purposes. Don't put it into this web of failover and global distribution. So that allowed us to build something that looks like this. On the left is our US East 1 region. On the right is our US East 2 DR region. Let's see, CloudFront, Route 53 are global services, so they kind of move up out of the VPC diagram. What else we got here? We're replicating S3 buckets. We're replicating database to our DR region. And with GitLab, we're actually deploying into both regions actively, right? So in this setup, failover is basically, resize the database, fail over the cron tab, maybe do another deployment, right? It's a lot better than this scary document that somebody I hardly remember left me. These environments virtually identical in every way. The only way that they're different is one is the account management region and one is not. And in the longer term, we fully want to be working actively across these two regions. So the is account management flag, I think, is going to help us not only do that, but then work across more than two if you'd like. So we're really darn close at this point on the DR front, right? Like, this is not bad, it's workable. It could be more automated, sure. So how do we actually use this magical Boolean? Here's two examples. In the first example, we have a transit gateway. And a lot of Amazon services, if I want to go create a transit gateway or an S3 bucket, and I want to turn on replication, I have to have the bucket I want to replicate to before I can start replicating. Right, so that's kind of backwards. What we do is we use this is account management flag to actually do peering. So we establish a primary Terraform provider in the account management region. So in this case, US East 1 always has the main transit gateway. As we go and run this Terraform in other regions, like US East 2, which is not the account management region, it knows through this, or by the provider line there, we are able to create the attachment for the new transit gateway in East 2 in more of a peering sense, right? I have this one, I'm putting a new one, I want to put a third one, I want to put a fifth one. That's all totally possible with this, I think. Maybe not with account 0, but. So there's also times where providers that have really robust Terraform providers, companies like Twilio, companies like GitLab, who we can automate all of the things we use, and then we can start to take the outputs and push them back into Secrets Manager, back into clusters and so forth. This flag allows us to kind of just do it once, right? I need one Helm registry token. I have one Helm registry. I have in Argo, it needs that token. I don't need one per region in this case. It also pops up on our control plane a little bit, our sort of internal control plane. You think about BI tooling, right? Like I don't need a disaster recovery BI yet. I might at some point, but I don't yet. And if we actually go into a failover, like BI is going to be the last thing on my mind personally. Okay, so requirement 7, sort of the last little piece of the puzzle for us. We want to go multi-region, right? Our APAC customers, they demand a better experience. Some of them as far away as New Zealand, really long request flights. And our business also kind of wants to get some cloud footprint over there. So our data protection officer and I, we decided it's best to go with a multi-instance approach. We did some research. We found a really great article about how Atlassian designed their data residency. And we effectively decided we're going to have to put little silos around the world. And then within those silos, we're going to have disaster recovery pairs, and it's going to be great. So we do that, right? We add another layer over all the things that we just saw. Ultimately, I think the final form is 3 new geos, so US, AP, and EU. And then, like I say, each of those with a DR region as well. So 6 regions per environment. Challenges here, right? We talked about data sovereignty and data residency earlier. I think a lot of that was kind of handled by the siloed approach. But it creates some other problems, right? Now we're moving the compute, the processing, the content storage and distribution to a different part of the world. It's great for them when they're at home, when they're on their couch, on their cell phone, they're having a good time. But then when they go from, say, Australia to South America, we've just put them in the same position that they had with US East 1. Just a different network that it's going across, right? The other big challenge, like it should go without saying, this is a new installation of a pretty well-established SaaS app. It's like a 10-year-old product at this point. We've only ever had one install of it, so we had to really dig deep into how is the app configured, right? And we had to kind of do it with some pending customers. People want to use it. So how do we solve these problems? We want to be able to partition the replication and the compute. We want to be able to keep it compliant, so that requires geographic segmentation. We wanted to adhere to all the other big new ideas that we talked about. And again, we want to not mess it all up because we sort of have one chance to get this right. The bottom right of this screen, a very simple example about how we deal with the cross-region replication. So again, we have a map. This map is keyed off of the geo, we call it. That's just the 2-character prefix on the region. And we make some assumptions that within the US, we can basically replicate wherever within the US that we want, local guidelines allowing. AP is a little bit different, right? Like AP Southeast 2 is Sydney, Australia, but like I may not want to put the replica in Singapore. It's going to go across an ocean. It's going to go to a completely different continent with different restrictions. So we map that out here. And then we use a couple of locals' primary replication region, like for the current area geo that I'm in, which one's in charge? Am I that one? And then give me all the regions that I can actually replicate across. So we managed to get East 1 and East 2 working at a kind of grid level at this point. But we're actively starting to serve traffic out of Asia Pacific. We haven't had to write much new Terraform. We've just had to add config and add them to maps like these. And it starts to come to life. Right? We want to add another new region. I want to maybe replicate to California. I just slap it in the list, run some Terraform applies to make sure all the configuration comes along for the ride, and there we go. Pretty painless. I think each one of my team members has done it maybe at least once or a half time each so far, but it's been not bad. Like we just open the files, scroll down through the variables, and make sure the environment's defined. So applying it to resources, here we have a global RDS cluster. Excuse the US geo one over there. Again, trying not to blow up databases that are older than I am. In this example, we're using the is primary replication region to make sure that we only install the RDS global cluster in that one area, right? And then we use not is primary replication region to create the replicas for the database, right? So it's kind of the inverse. And this kind of works out pretty good for us in the long run. Like, we looked at the complexity of the app square and the apps DR square. And excuse the squiggles because they're just network wires and stuff. But you can see, like, we're able to make a lot of resources. And we didn't really increase our Terraform much. We just kind of had to start using count more, start using these Booleans and conditionals more. And, you know, hopefully you can appreciate, like, how much complexity there actually is here, because it's like thousands of resources. All right, one other part I wanted to talk about before we wrap. 100% of this is made possible, like I said, with cloud native tooling. We spent an immense amount of time trying to make sure that SREs and developers don't have to put hands-on secrets, that we don't have to kind of reverse engineer the app over and over to figure out what the secrets mean and do. And I think any given nut and bolt that I've talked about is probably worth a talk of its own, but this one's probably more than one talk. At the highest level, we give Terraform a bunch of secrets in. We provision resources, databases, caches, things like that. And we reflect the credentials and the URIs and things back into Secrets Manager. And then we use tools like External Secrets Controller in Kubernetes. We use tools like Helm to pull these back out into compute land. The pod gets its configuration, none the wiser about where it came from. And we have happy developers and happy SREs, right? The whole secrets flow from provisioning a resource to consuming it in the app, just completely automated at this point. All right, so today we looked at how Teamworks SRE uses, maybe abuses Terraform a little bit to distribute our application across multiple data centers around the world. We looked at some of the turmoil it took to get there, and a little bit about how we manage configuration across our fleet. My name is Berzinskas. Thanks for coming to my talk, y'all.